Hello students, today we are going to see this topic DBMS database models. Okay, so last class we have seen different properties or different concepts of DBMS. So in this class we are going to see this DBMS database models. Okay, so the database techniques comes into existence in terms of models with relation and object related behavior. Object relational behavior. The major database models are listed below. Okay, so there are so many database models here. So the first model we are going to see is uh, hierarchical database model. So you can see that there are so many different levels of database objects. Okay, so here you can see that first is company level, and the next is user, machine, device, application level. Then at the next level you can see that marketing, personal level. Okay, so here you can see that so many different kinds of database models are combined to form one database model. Okay, so this is known as hierarchical database models. So this famous hierarchical model was IMS, which is also known as IMS, Information Management System. So this information management system was IBM's first database model. So in this model, each record has information in patient-child relationship like a tree structure. Okay, so if you create a database structure by using this tree format, okay, so then it is known as hierarchical database model. So and here you can see that the collection of records is called as record types, which are equivalent to table in the relational model. Okay, so record type and the table are both are the same thing, but the name which is given here in this hierarchical database model and the relation model are the different things here. Okay, so the individual records are equal to row. Okay, either in hierarchical database model or in relational model, individual record is known as row. Okay, so in the above model we have many advantages like less redundant data, efficient search, data integrity, and security. So this model also have this model also has few limitations like complex to implement and difficult to handle many to many relationship. Okay, so this advantages of this hierarchical database model is it is it it has less redundant data. Okay, so accessing the data in the hierarchical database model will be very easy. Okay, very easy. It has less complexity. Okay, so and security also has been improved. Okay, so this model has some limitations also, so it is very hard to develop. Okay, so if you want to implement this hierarchical database model in any project, then it will be a time consuming one. Okay, so and it is very hard to handle many to many relationship. So the first thing here is the next database model is a network model. So the first developed network data model was IDS, integrated data store, at Honeywell. So Honeywell is a company which developed this IDS, integrated data stores. Network model is similar to hierarchical model, except that is this model each member can have more than one owner. So the many to many relationship are handled in a better way. So this model identifies the three basic components: network schema, subschema, and language for database data management. So here you can see that these are all the key features of network model. Okay, so the network model is same as hierarchical model, but it has many owners for a uh, um, single member or single entity in the model. So in the next paragraph you can see that this is network schema, subschema and language are being defined here. Okay, so schema defined all about all about the structure of the database. So schema means it is creating a structure for the database. Subschema means control on view of the database for the user. So the subschema will provide control. Control means the workflow of each entity or each schema in this network model. Okay, so now language is the actual process. Basic proceed for accessing the database. So basic steps to access this database. So the major advantages of this model is major advantages of this model is the ability to handle more relationship type, easy data access, data integrity, and independency. The limitations of the network model is difficult in design and maintenance. So here you can see that the advantages of network model is it can handle many types of data, and it provides data integrity and independency. So each model will not be connected to another model, so that it will be creating a more complexity. So it is advantages here, and the disadvantages is here is it is very difficult to maintain means if you create a network model, then one entity will be accessing it, and another entity will be recording it. Okay, so you have to maintain both the things in a effective way to provide a effective accessibility of data. So the next thing is relational model. So Oracle and DB2 are a few commercial relational model in use. Relation model is defined with the two terminologies, instance and a schema. Okay, so these two terminologies are instance and schema. So this instance and schema are the main important thing in this relational model. So here you can see that this diagram will provide you detailed description about the instance. Okay, so instance is a table consists of rows and columns. Schema is specified structure including name and the type of each column. So here you can see that, so member is an instant, and member group is an instant, and group is an instant. So each of which is related by a single entity which is known as id. Okay, so id in member is related to member id in member group and id in group. Okay, so it will be related to each other. So instant is a table consists of rows and columns. Okay, schema is the structure including name, type, and each column type of each column. So here you can see that schema in member table or member instant is id, first name, surname, and email. Okay, so these are all the schemas in member instant. So the schema in member group is member id, group id. So these are all the schema in member group. And group is an instant which consists of only one schema, which is id. So you can create multiple rows based on this schemas. Okay, So this is known as relational model. Okay, relational model. Each scheme, each instant will be linked together with a particular ID or any individual key elements. Okay, so the next thing here is object-oriented database. So this model incorporates the combination of object-oriented programming concept and database terminologies. Okay, so this object-oriented database model is combination of both object-oriented programming concept and database terminologies. So here you can see that practically this model serves as a base of relational model and object-oriented model. So on the next page you can see this clearly. Okay, so this is object-oriented database model. Here you can see that each entity will be provided to you with with a precise set of data. Okay, so here you can see that user. So object-oriented model uses small reusable software like known as objects. Okay, so it is an object which is stored in which is very small reusable piece of code. Okay, so these are stored in object-oriented database. This model efficiently manages large number of different data types. Okay, moreover, complex behaviors are handled efficiently using OOPS concepts. OOPS means object-oriented programming concepts. So these are all the different types of database models. Okay. So next we are going to see this relational database management system. So far we have seen what is database and what is database concept and the database models. Okay. So now today this part is relational database management system. So it is a software. So this software is capable of doing database management system work. Okay, so a database whose logical organization is based on relational data model known as relational database. So DBMS, database management system that manages the relational database, is known as relational database management system. So here you can see that it's a bit confusing, but it is very easy to understand. Okay, so database model uh, which which consists of relational data. So a database model which uses relational data is known as uh, RDBMS, relational database management system. So DBMS that manages relational database is known as relational database management system. Okay, so the software which manages relational database management system is known as RDBMS. Okay, so RDBMS is basic for SQL, structured query language. SQL means structured query language, and for all modern database system like MySQL, Oracle, and Microsoft Access. This SQL is the basic programming language. Okay, so if you want to use MySQL, or if you want to use Oracle, or if you want to use Microsoft Access, then SQL is the basic one which can be used in any of the RDBMS software. So the basic RDBMS concept includes database, tables, tuples, attributes, schema, key, which will be discussed in the RDBMS jargons. So here if RDBMS jargons, which is the next topic here. So the most popular relational database in a relational database is MySQL. Obviously, you can see that most of the projects which are implemented in a very small scale or in an effective way, then MySQL will be used. So if you want to be more secure and more efficient, then you can use this Oracle. Okay. So MySQL is an open source SQL. Okay. So it's an open source SQL database supporting different platforms like Windows, Linux, Mac operating system. So the other relational database available are Oracle, MS SQL Server, and MS Access. So this MS Access and Microsoft Access are the same. So this the features of RDBMS is high availability, high performance, robust transaction and support, ease of management, and less cost. So these are all the features of RDBMS, and you can see that next is table. Okay, so in obviously when you are using RDBMS, tables will be there. In the tables you can see that columns, rows, key, foreign key, super key, and composite key. Okay, so these are all the different things that we are going to see in the upcoming chapters. Okay, so first one is table. So in the relational database model, table is defined as the collection of data organized organized in terms of rows and columns. Okay, so you can see that in a table it will be having rows and columns. So here you can see that there is one sample table here, table 3.1. so in that you can see that 4 columns are there and 4 rows are there. Okay, so ID, name, age, salary are columns, okay, which consist of ID, numbers, name of the different users, and the age of different names, and the salary of their uh, employer. Okay, so here you can see that employees. Okay, so vertical data is known as column, and the horizontal records, okay, are known as rows. Okay, so in a row you can in a table you can have multiple rows and multiple columns. Okay, so table is simply is a simple representation of a relationship. The two relationship cannot have duplicate rows. Okay, so here you can see that in the database uh, two same rows cannot be present there. Okay, so if the same row is present in the same data, then data in the same table, then it will be considered as duplicate row, and it will be very inefficient way to provide duplicate elements. Okay, so mostly all the database will be having a separate feature which will detect duplicate rows. Okay, so if you are uh, wantedly providing duplicate element, then it will automatically tell you that you are entering a data which is already available in the database or already available in the table. So 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 this is the example of the table. Here you can see that in this screen. Okay, so next is column. So the table consists of several rows and columns. Tables can be divided into smaller parts in terms of columns. Each column is known as attributes. In the employee table, 4 attributes are available, namely uh, ID, names, age, salary. The attributes is defined in the table to hold value of the same type. So this is known as attribute domain. In the same employee table, the name field will hold only characters, not the numbers in it. The vertical entity of the table is known as attribute or column. Okay. Next is row. So a single entity in the table is called a row or record or a tuple. So set of related data are represented in a row or tuple. Okay, so the horizontal entity of a table is known as record or a row. So here you can see that they have given a table which is known as table 3.2. So in that it has only one record or one row. So which ID is 1 and its name is Alex and the age of Alex is 26 and is getting 22,000 as salary. Okay, so this is a row here. Okay, whereas in the previous example we have seen three rows in it. Okay, and the next thing you want to know is primary key. Okay, so primary key uh, is the candidate key that is chosen to perform the identification task is called primary key. So this entire row is identified by using this ID. So if you want to get the name of a person who is getting salary 22,000 and his age is 26, then you can use this ID number. So you can use what is the name of ID1. Okay, so then this database will go and search for ID1 and get the name of the respective record. Okay, so this is a way of accessing the data by using ID. Okay, so the primary key is the identification part of the individual record. Okay, so each tuple must have by definition an unique value for its primary key. A primary key will which is combined which is a combination of more than one attribute is called composite primary key. Okay, so here you can see that in the table ID is the uh, primary key, but you can use one or more key. Okay, for identification. So if you are using one or more than uh, so many keys in a table, then it is known as composite key. Next is foreign key. So foreign key copy is a copy of primary key, so that has been exported from one relation into another to represent the existence of the relation between them. So a foreign key is a copy of the whole of its uh, parent primary key. That is, if the primary key is composite, then so is the foreign key. The foreign key value does not have to be unique. Foreign key can also be null. The composite foreign key cannot have some attributes and other non-null. So here what you want to understand is foreign key means copy. Okay, so primary key will be copied as foreign key in some other table. Okay, so you can have multiple uh, elements. Okay, same for the primary key. Okay, so even this foreign key uh, can be null value. Okay, so that's the thing that is explained here in this foreign key. And the next thing is super key. Okay, so an attribute or a group of attribute which is sufficient to distinguish every tuple in the relation from every other one is known as super key. So each super key is called candidate key. Okay, so you should not get confused when saying super key or candidate key, both are the same. So the candidate key is selected from the set of super key. So so while selecting the candidate key, redundant attributes should not be taken. So the candidate key is known as minimal super key. Okay, so you cannot select redundant data, which means that uh, inefficient data. Okay, duplicate data cannot be accessed as a super key or a candidate key. So this is the definition for super key. And the next is composite key, which is already discussed in the above topic, which is primary key itself. Okay, so with this we'll finish the class. Next class we'll see this ER model. Okay, so thank you, students.